Bismillahirrahmanirrahim. Assalamu alaikum, students. Here is Mubashir Riaz, and today we are going to start our chapter number 5, circular motion. So, in this unit, we will discuss about different terms which are related to the circular motion of an object, like angular displacement, angular velocity, angular acceleration, and which type of force is required to keep that object in a circular path. So these are the key points of chapter number 5. So let me discuss first of all what is circular motion. So circular motion can be defined as the motion of a body in a circle is called circular motion. कि when object is following a circular path, कि जब एक object circle में move कर रहा है, circular path को follow किए हुए, then this type of motion is called circular motion. For example, motion of moon around earth is a circular motion. Similarly, the motion of electrons around the nucleus is also a circular motion. When electrons are revolving around the nucleus in their particular orbits, so this type of motion is also called circular motion. Similarly, there is another example, which is motion of a stone that is attached with the end of a string. When it is whirled, then it is also a circular motion. So motion of a body in a circle is called circular motion. Now there are different terms which are related to circular motion of an object. So one of them is angular displacement. Angular displacement is the angle which is subtended at the center of circle by an object which is moving along the circumference in a given time. So this is called angular displacement. In other words, we can say that the displacement covered by a body in a circle is called angular displacement. कि वो डिस्प्लेसमेंट जो एक ऑब्जेक्ट सर्कल में मूव करते हुए ट्रेवल करता है, कवर करता है, that is called angular displacement and it is represented by theta. For example, in this diagram, we can observe that there is a particle which is following a circular path. So let it moves from the initial position, from its starting position, from this starting position to this ending point. So this is the angular displacement covered by this moving body in a circle, and it is represented by theta. So this is the angle which is covered by the moving body in a circle is called its angular displacement. For a small value, angular displacement will be considered as a vector quantity. एक स्मॉल वैल्यू के लिए आप एंगुलर डिस्प्लेसमेंट को वेक्टर क्वांटिटी के तौर पर ट्रीट करेंगे. फॉर एग्जांपल, इन दिस डायग्राम वी कैन ऑब्जर्व दैट ऑब्जेक्ट स्टार्ट मूविंग फ्रॉम दिस पोजीशन and then it reaches to this position point P1 and it covers some angle theta, and then in a very short interval of time delta t it moves from this point P1 to another point P2. So this displacement covered is very small, and this displacement covered will be considered as a vector quantity, and normally it is represented by delta theta. So delta theta is the smaller angular displacement in a short interval of time. If it is a vector quantity, then its direction can be determined by using right hand rule. And what is right hand rule here? Grasp the axis of rotation in right hand in such a way that curl fingers are in the direction of rotation and stretched thumb represents the direction of angular displacement. यानी आपने right hand को इस तरह इस्तेमाल में लाना है कि आपकी curl fingers direction of rotation में होनी चाहिए, और direction of rotation is either clockwise or anti-clockwise. So if object suppose it is moving anti-clockwise, then this is the right hand rule. So if object is moving anti-clockwise, then your curl fingers are in the direction of rotation, which is anti-clockwise, and your stretched thumb represents the direction of angular displacement, which is acting along the axis of rotation. So with the help of right hand rule, we can determine the direction of angular displacement. Now, what is the unit of angular displacement? So we can use 3 units to measure the angular displacement. One is degree, other is radian, and third one is the revolution. But SI unit of angular displacement is radian. Radian is the SI unit of angular displacement, where degree is the smaller unit and revolution is the larger unit, but radian is the SI unit of angular displacement. So what is meant by degree? Degree क्या है यहाँ पर? Degree can be defined as if the whole circumference of the circle is divided into 360 equal parts. कि अगर हम एक सर्कल के सर्कमफेरेंस को 360 इक्वल पार्ट्स में डिवाइड कर देते हैं, then each part is representing 1 degree. Then each part is equal to 1 degree if whole circumference is divided into 360 equal parts. Now what is radian? Radian is the angle which is subtended by an arc at the center of circle whose length is equal to the radius of circle, and it is measured in radian. For example, this is an arc. From this point to this point, this is an arc. So length of an arc and radius of circle, if they are equal to each other, this is the condition. Arc length should be equal to the radius of circle. Then angle subtended by this arc at the center would be equal to 1 radian. So this condition must be satisfied. Arc length and the radius of circle, they must be equal to each other. Then angle is equal to 1 radian. And the last one is revolution. So revolution can be defined as one complete round trip of a body about a particular point is called one revolution. जब एक ऑब्जेक्ट साइकिल में घूम रहा है, सर्कल में रोटेट हो रहा है, मूव कर रहा है, तो उस दौरान अगर वो एक चक्कर मुकम्मल करता है एक फिक्स पॉइंट के गिर्द, so this is called one revolution, and these 3 units are related as one revolution is always equal to 2 pi radian, and it is also equal to 360 degree. So revolution is the larger unit, radian is the SI unit, and degree is the smaller unit. So one revolution is equal to 360 degree as well as it is equal to 2 pi radian. Now there are 2 short questions. Number 1, prove that S is equal to R theta, which is actually the relationship between linear displacement and the angular displacement. Here theta is angular displacement, S is linear displacement, and R is the radius of circle. So to prove this relation, let me consider an arrangement which consists of a body. It's moving in a circle of radius R. Let it moves from point P to P1. Here P is the initial position, P1 is the final position. Then angle made at the center of circle is equal to theta. This is an arrangement where object is moving in this circle. So here P is the initial position and P1 is the final position. So object moves from P to P1 and its displacement covered is equal to S, where R is the radius of circle. So angle made at the center of circle by this arc is equal to arc length over radius of circle. Here arc length is P to P1 and radius of circle you can write either OP or OP1, because O to P as well as O to P1, this is the radius of circle. Finally, theta becomes equal to S over R, which can also be written as S equal to R theta. तो ये वो रिलेशनशिप है जिसको हमें यहाँ प्रूव करना है, जो कि S और थीटा के दरमियान रिलेशनशिप है, where r is the radius of circle. And there is another short question. Prove that 1 radian is equal to 57.3 degree. 1 radian is equal to 57.3 degree, and we can prove this relation by using S is equal to r theta, where theta is equal to S over r, and if object completes one rotation, then distance covered by the body is equal to circumference of circle. यानी अगर एक ऑब्जेक्ट एक चक्कर मुकम्मल करता है तो चक्कर मुकम्मल करने पर उसका जो डिस्टेंस कवर्ड होगा वो सर्कल के सर्कमफेरेंस के बराबर होगा, which is equal to 2 pi r. So by putting the value of s equal to 2 pi r, this relation becomes 2 pi r over r, जहां r कैंसिल हो जाएगा, and theta is equal to 2 pi radian. लिहाजा यहाँ ये भी प्रूफ हो गया कि एक साइकिल कंप्लीट होने पर सेंटर में एंगल कितना होगा, that is equal to 2 pi radian. From this equation we can deduce that one revolution is equal to 2 pi radian and it is also equal to 360 degree, जबकि हमें प्रूफ करना है relation between radian and degree. For this purpose 1 radian becomes equal to 360 over 2 pi. इस 2 pi को आप right पे ले जाएंगे तो ये divide हो जाएगा. So 1 radian is equal to 360 over 2 pi, where pi is equal to 3.14. Hence 1 radian is equal to 57.3 degree. So this is the relationship between 1 radian equal to 57.3 degree. यहाँ आप याद रखेंगे कि जब भी सेंटर में एंगल 57.3 डिग्री बन रहा होगा तो उस वक्त आर्क की लेंथ और सर्कल का रेडियस ये हमेशा एक दूसरे के इक्वल होंगे. Arc length would be equal to the radius of circle if angle subtended by the arc at the center of circle is equal to 57.3 degree. So this was the first term related to the circular or angular motion of an object known as angular displacement. So next time we will discuss about angular velocity and angular acceleration. Thank you.